Hey everyone, this is Sina with another episode of Into the Byte Code. My guest today is Jeffrey Quesnelle, one of the co-founders of Nous Research. So this was a pretty wide-ranging conversation. Nous is a research lab doing work to move open source and decentralized AI forward. And in this conversation, we talked about AI more generally. So we talked about the technical progression of the field over the last decade plus and what the big inflection points have been. We talked about modern model architectures and how things like reinforcement learning might have parallels to how the human mind works. We also talked about how each of us more philosophically relates to this moment in time and to the idea of us creating intelligence for the first time. So this was a lot of fun, and I hope you enjoy.
I'm stuck in my ways, and I see that 20 years from now, I'll be the gray haired, just like sort of when I was growing
Using
up, or
Emacs.
there's these, Unix people who use V all the time and they refuse to, they wouldn't even open into like a GUI, right? And stuff like that. And they say, well, you guys just don't understand. They wouldn't write in C++. Like C++ was this like, you can't write it in, C in 80 width, character width, it's not worth writing. And so there were people like that. But then there were like the young kids like me, or I'm like, ooh, I'll use objects and pointers. And yeah, it's kind of ugly and maybe it's not the most, but like it works, right? And likely that will be the situation that it goes through. I question this myself. I'm only like a very light AI user myself, to be honest with you. I spent all my time using, working on AI, but I use it very little. And especially for coding, the problem is that, having been coding for 20 years, the problems that I can't solve are usually extremely nuanced. If it's like and that's usually like at the edge of where LLMs today like can really, with like hallucination, like it's usually like very nuanced things that like are the problems. Or the problem isn't in the code in particular, it's in how you're approaching the problem from like a meta perspective, the organization having the actual instantiation of your different servers you have and your infrastructure, stuff that like AIs today can't really like break out of their box and like actually experiment. Now, having said that, one thing I want to caution everyone is that every goalpost, every it can't has fallen mercilessly in the last 5 years, right? So it is very likely that within the next 2 to 3 years, all those things will not be true, and there will be AI models that can that will have full agentification, which means they'll be able to run experiments, do things, touch the real world in some way. And their reasoning ability over code, over all this stuff will just be superhuman. It will truly will be better than the best humans on the planet. So how I will interact with the world in that case, remains to be seen. One thing I would know, and it's already going to sound like a gray hair, is that, there is something to be said for being forced to figure something out yourself.
Oh, 100%.
Insofar as you value your own understanding as much as you value sort of your economic output, right? You view yourself as like, what can I do for what am I doing to the world? And that's your economic output. Can that be replaced by an AI? Probably, like in a lot of cases, right? But understanding something yourself, an AI can't understand something for you because it is not you, right? And so there is value, there was economic value often in being able to understand something because that was the only way you could get it done, right? But it may be now that that isn't the case. I saw a meme recently where it was like, it's like, it's sort of from Lord of the Rings, where the time of the orc has come. It said like the time of the idea guy has come, right? Because like everyone who's just got an idea can now like implement it without having to go through like and maybe that's all humans are really the best at anyway. So we'll see. But for me, I'm still very much, I want to get through it, and I find value in understanding things. And
Well,
yeah.
I've been struggling with this question because in a world where, even assuming that AI continues to improve significantly from where it's at today, especially in these more verifiable domains where we can just fire off these agents and they can write, implement entire features, like do scientific research, where there will be the human in the loop is to kind of have the taste and the judgment of what are problems that are worth kind of
What
look
ought to be done?
what
What
ought to
ought
be
to
done,
be
and
done? Yeah.
then to actually at the highest level possible to evaluate the work output that these AIs are generating for you. And to be able to do those two things, you need to kind of still have a very strong, like fundamental, like mental model of the world. And if you and that to me, it's kind of orienting me towards focusing more on the fundamentals and like the scaffold of my understanding and knowing that I can kind of fill out the details with AI. And but you really do need to be able to derive, like think from first principles about those two questions.
Yeah, and, it will become very easy to use these as crutches and to never develop that understanding, right? Because you always can just get the answer. It's like you got the textbook, but, like, every answer is right in the back of the book, you know? And there's always gonna be this, like, temptation to look in the back of the book when you don't have the answer to the problem.
Yeah. So maybe to continue in the storyline before we go into some of the neural network fundamentals, how did you end up starting Noose? And how did you meet your co-founders? Because I feel like you guys seemed like an interesting cast of characters.
Yeah, yeah, it really was one of those, right time, right places thing. I like to tell everyone we're just homies on the Discord who got big. But really the way it would started was I was working on this literary AI project, and like I said, the only best model that they have was this T5 model that only had a 512 token context length. Then Llama came out and it was 2K, and it was like whoa. But then ChatGPT comes out and it's 4K. And I'm like, oh, how are we ever going to get there? And it seemed like at the time that this was like, an insurmountable barrier. And I'll pause for a little bit and say, why did I choose this choose your own adventure thing? I'm a huge fan of books, right? Like science fiction, fantasy, stuff like that. Um, and I grew up reading Choose Your Own Adventure, all these Choose Your Own Adventure novels. But I am not very creative or artistic in anything. I'm a terrible creative writer. I'm a terrible drawer, right? But I'm a really good coder, right? And so I saw AI, these tools, as a way for me to express myself, in a way that I couldn't before. Just as much as like computers had taken people who couldn't do analytical thinking and can do it for them, like we sort of solved, if you were right brained, we can do the left brain stuff for you, right? But we hadn't solved your left brain, we can do the right brain stuff for you, right? And finally I saw this and I'm like, it is a tool that will allow me to do this thing that I couldn't do before. I can do all the left brain stuff, I can't do all the right brain stuff. So that's why I chose this as, and speaking back to like this humanistic element, I hope that where we take this technology in the future is in that view of creating fully rounded people that can, that are better expressive versions of themselves, that they're better versions of themselves with the AI all around than they are without. But anyway, as to say that, I was working on this, project for being able to choose your own adventure stories, shoot super short context length. And so I started to figure out, like, was there a way we could like make these context lengths longer? And it turns out you can just like, I started just like, literally trying shit. You know what I mean? Like I'm in the Python code. Like I wonder if I do this, what happens if I do this? And it turns out that with Llama, there was like this trick you could do where you could divide. There's these things called positional embeddings. So what a positional embedding in a model is, it basically you inject into, if you think about like these matrix multiplications internally inside the attention mechanism, the dot products, like they're all like every row is being multiplied by every other row, and these like correspond to the tokens. So without the positional embeddings, the model actually sees the sequence as a bag of words. It actually doesn't know, like, and believe me, it's crazy that this even like worked before. Like it didn't even have, the original Transformers, like they showed you don't even like need these positional embeddings, but it's much better if you somehow inject into the model some information about the order of the words, obviously, right? And so, but the problem is that for some reason, what happens was that once you went past sort of the sequence length that the model was trained on, it had like never seen anything be. It thought the entire world could only ever be 2,000 words, right? Like, and you think about like the internal representation this world is these models like are developing, right? Like, if you it thinks that's just a fundamental law of nature, it's gravity, it's thermodynamics, right?
Like
To
the
words can only ever
architecture that
be.
it's been trained on, it thinks is the
Yeah.
entire world.
Yeah, it is its own world, and it has never seen a piece of text longer than 2,048 words. And so at 2,049, it doesn't know what to do, right? So, and that's just and it just so happens to learn that way. But it turns out that you could like, I was just in PyTorch, like screwing around, and I'm like, well, I saw where these positional embeddings are, right? I'm like, well, what if we like just like multiplied all of them by like a half after we've trained? Because these are actually like floating point numbers. See, that's like what's really weird. If I had to give you like a difference between AI and computer and like regular programming, it's regular programming deals with integers and AI deals with floating point numbers. And that's like all of the magic and elasticity and plasticity comes from stuff like this, right? So I was like, well, what if we just like divide these numbers like by half and I just like get it, right? And all of a sudden the model could like go to like, 4K words, right? And it was like, this can't, what? How is this even real? I thought this was like a fundamental, limitation. But really what you're doing is you're being like, because the position numbers are like floating point numbers, you say, well, these aren't 1 and 2, these are at 0.5 and 1. And so you can like squeeze extra information because like the relative distances, like it picks up that like you can do these floating point differences, and you like squeeze 4,000 words into 2,000 words by saying that they're at position 0.5 and 1 and 1.52, right? And it just works. And so I posted on Reddit that, there's this local llama Reddit, right, that like had it. And so I posted on Reddit like, hey, you can like do this thing, right, that like will make these models bigger. And out of that, Bowen, our chief scientist now at Roost, just messaged me, was like, hey, I've been working on something like this too. And he had like an even more advanced version. And he sent me like all these charts, and we started talking. And then I posted about it on Twitter, and Technium, who is kind of like a, he's a Twitter famous, I guess is the best way to put it. He, messaged me on Twitter. It was like, hey, I saw you were working on this stuff. Would you like to join this Discord of like researchers? And I was like, sure. And I joined it, and this was a private Discord at the time. There's only like 30 people in it. And I looked at the list, and I like knew who all of them were. It was like all
Wow.
these open source researcher people. So I thought I'd broken into the club, right?
Made it.
And that Discord is the Nous Research Discord today. Like that
No
eventually we
way.
opened it up and made it public, yes. But like it started out as this core of like open source people who were, working together. And it was kind of like the insider, like the Secret Boys Club. It was the group chat of the open source people, all the open source AI researchers. And so out of that was how Nous started. And it kind of all came out of this thing of, this infinite curiosity of just being like going through the code and being like, since I'd stepped through it all, like, well, let's just try something and see what happens. And I'll tell you, that's what's really great about the AI space right now is that it's this like vast, infinite field of unexplored science, right? You have situations where, like in like chemistry and biology, right? They're very like ossified physics, you spend your whole life working in physics. You never even understand the modern like the state of the art, right? Like you spend your whole life trying to get to the point of understanding state of the art physics. And if you're very, very lucky, you might make like a tiny contribution. Whereas like in the AI space, like you can just try something and it probably will work. And it isn't because if you have an idea, it isn't because it doesn't work. It's probably because just nobody's tried it yet, right? And like that's really like a powerful and exciting time to be in a formation of a science.
Well, that's a bit counterintuitive because usually it's like there's so much attention going into AI where you would almost imagine some version of the efficient market hypothesis, right? Of there's all these researchers, all these engineers like working on AI. There must be nothing else to look into at this point in time. And I should, work through the ramifications of this and go on work on the thing that comes after all of these problems are solved. But you're saying that there's like open greenfield right here.
Yeah, I mean, every few months are new discoveries about architectures, about data, and they meaningfully advance the state of the art. Take a look at what happened with DeepSeek. It turns out that like these were not like the application was special, but like the ideas were actually pretty simple, right? And just no one had tried it. They introduced this thing called multi-latent attention in DeepSpeak too. And, you know, is how they're able to deal with these super long contexts without it blowing up the memory. So there's like, can you do it? And then does it take a huge amount of memory? And so they developed this thing called multi-latent attention, where basically instead of having the full matrix multiplication, they like do this low rank projection of the Q and K, which are the query and the key pieces of the attention mechanism. And they just like project them to a lower dimension, do the attention on the lower dimensions, and then scale it back up. And this like, it turns out that like this means that your memory usage go down like 90%, right? And guess what? It still works. Like the evals are exactly the same. You know what I mean? Like these are like 5-line, like things like 5-line codes a lot change can like be the difference and make it. And that's really because those 5 lines are operating at scale. That's really like the thing that has allowed AI to grow is this scaling idea, right? Which is that if you make it bigger, it will just be better, right? And this is on both dimensions. Like if you give it more data, it just will be better. If you give it more computer and make the model bigger, it will just be smarter at qualitative human reasoning. And the idea that like we could do that, like we know how to scale things on that dimension easy. We don't know how to scale things with people very good, but like throw more money, it's basically like a throw more money at it problem.
Yeah.
And like if it's just a throw more money at it problem, like we can throw more money at it as a society. Yeah.
Which also speaks to the value of Nous in its current incarnation, or Psyche in these networks that you're building, because then the bottleneck becomes, okay, can I go raise funding, and can I like procure a bunch of H100s to train a model and to test this idea that I have? But now there's this more plug and play network that I can just upload my idea into, and it magically gets trained for me.
Yeah. Yeah, so that's what we're trying to build with Psyche. So with Psyche, basically, after we had this, about a year ago,
maybe to go from where we were to Psyche.
Yeah,
because I really like hearing this story of how this Discord just became the Nous Discord. How do we go there from there to here? Like, what were the big inflection points in the story? Because you guys are making your progress, but also the whole AI field is also changing in massive ways.
Well, definitely for us, for Nous, it started from this first principle of wanting to be able to, run the AI at like this whole idea, like you should be able to step through the whole code and be able to access it and see it all, right? And I've got my 4090 there, and I want to be able to like run the model through and step through it. And so, Zuckerberg did a great service for the world when he released Llama, because it forced people to realize that like there was no real inherent moat. Like there was a moat, but there really wasn't. So but after we formed up together, we said, all right, we have our mission, and our mission is to be the open AI accelerator. We want to, every time there's like we did with this context, whatever it is, whenever there's like a barrier to the open source world being able to access this tech, like, let's just go knock it down, right? Whatever it takes. And so we kind of looked around and we said, well, what are some of the what are some more barriers that exist, right? Like, okay, we know how to do certain classes of things. And really one of the things that came to us is just the entirety of the open source ecosystem for models is dependent on a benevolent third party releasing a foundation model. We can, if you want to talk about what a foundation model is or stuff like that.
We'll get into it.
Yeah. But it requires this thing called a foundation model, right? Very expensive to create. There at the time there was just Meta and maybe like Gemini released, or Google released the Gemma, but it was kind of new. Like there was like 2 or 3 people, putting out these foundation models, and we're like, well, what happens if Meta just stops doing this? What happens if like we just don't get Llama 3? This was before Llama 3 even came out, or we don't get Llama 4, right? Because we know that the closed providers will continue on, right? They're already on the path. They're like, the race has already started. They're running, right? They have the ability to run. So the open community needs to be able to keep up in the race, right? But keeping up in that race was dependent on this like almost like economically unsound, activity from one of these other people. Like, well, that's trouble, right? So the question is, okay, what can we do so that the open source community has like a credible way to stay in the race? Well, we need to be able to train our own foundation models. Okay, all right. So what easier said than done,
Problem
right?
identified.
Yeah. So what is the real problem? What is the thing? It turns out that it's not actually access to data, right? Like the data that these AI companies have been training on, at least in the text modalities, is just basically the internet. Like anyone could get the data, and so it wasn't the data. It was access to the models in a way to actually or access to GPUs in a way to actually coordinate the GPUs. And so the problem was that the being able to train a model because of sort of this when the tech started out, you only had like one GPU, right? And the code PyTorch, it was written under this paradigm. It's called like the single device paradigm, right? And what the single device paradigm is that when you're writing the AI model, you write it as if you're on one GPU. And you logically think about it about as if it were running on one massive GPU, that like you don't think at all about the fact that it has to get split and stuff like that. And you could just kind of be like, matrix multiply. And like that one line of code is like, multiplying, instead actually ends up, running taking a megawatt of energy to do, right? Just to do that one matrix. But like on Python, it's literally like one line of code in Python, right? Or, to do this,
The
right?
beauty of abstraction.
And it was a beauty of abstraction because by enforcing the single device paradigm, it kept the complexity of the actual AI stuff like is very tight. Like you could open up like the GPT, the transform, like people famously, you could the GPT transform, like the code for a GPT is like 40 lines of code. Like it's literally like 40 lines of code. It's a couple of for loops, a couple of matrix multiplications, an activation function, a normalization, boom, you're done. That's it. Now under the hood, to make this work across multiple GPUs is like, it became clear that we were going to need to use multiple GPUs because we couldn't make them bigger. The tooling basically created these abstractions that would like do it for you underneath, right? It would like make it. And the way this was instantiated was that every GPU would like hold different pieces of the model, but like to really for it to be like fully flexible, you had to have it so that the GPUs like almost were like one big GPU. And the way this was solved was through this expensive routing fabric. So what they do is not only do people buy a bunch of GPUs, but they also have to then hook them all up together in a single data center, right? And the single data center, and they all need to be like connected like symmetrically, basically, right? Where like the latencies are the same between them all. They all have to be the same type of GPU, they all have the same VRAM. It's like really this like you scale by making this like infinite copies of the one GPU, and then you hook them up with this either Rocky or InfiniBand, which is like this extremely expensive, like it's 400 or 800 gigabits per second. In between the GPUs, the cables cost like $1,000 a foot, and stuff like that. But by doing that, you could move data between the GPUs arbitrarily fast. And as long as you could do that, it was very easy to keep that single device abstraction at the coder level, right? Because we know we can always just move the data around as fast as we want. And so that was sort of how the tooling built up. And so for training, all of the tooling and everything was written with this idea that you could have all these GPUs that were sort of like in one big data center and were completely homogeneous. And that, for us to do training on a distributed scale over the internet with lots of different computers, that's where you break down, right? Because the internet does not give you that. You have highly heterogeneous interconnect between the data, and just the total throughput is orders of magnitude lower. To give you an idea, the new GB200 racks from NVIDIA, which is their Grace Blackwell 200s that has 72 of them together with the new InfiniBand, the entire like InfiniBand connections between all the nodes is like equivalent to the entire bandwidth capacity of the internet. Like just in between all those GPUs connected, like is the entire throughput of like the entire internet in there. So that so that goes to show you that like we needed like several orders of magnitude reduction to make this even possible, right? That was like the fundamental technical limitation that we saw. So we sat down and we said, okay, could we like solve this, right? And we spent about a year working on the actual tech to be like, is there an actual fundamental reason why it has to be that you share all of the data all the time? Or is that more of like an artifact of Just that's how it kind of like the tooling made it be that you could do that. And we spent about a year working on that and developed a couple of new algorithms. One called demo and then like a more advanced one called distro that basically showed that actually you don't actually need to communicate everything between all the GPUs. You can actually communicate like a very, very small fraction of the data. Only like a very small fraction is actually needed. And sure, like if you're not like lazy, but like you can just share everything and it just works, like obviously. But like if you do this very, clever math, you only have to share these very tiny pieces. It's like the difference between if you had an infinite sized internet, we never would have had JPEGs. We'd all just be sharing bitmaps. We'd all just have .bmp files. We'd all be sharing uncompressed AVI files, right? Because you just could, right? If you had infinite storage and infinite bandwidth, there would never been a pressure that created the necessity for like compression, right? But once we started wanting to share pictures on the internet, we had to figure out JPEG, right? We had to invent JPEGs that could basically show you the exact same image at like a 1,000th the amount of information. And basically we took that exact same idea from JPEGs and we applied it to the gradient compression within these model training. And so now you had like this 1,000 to 1 reduction of bandwidth. And we said, okay, well now we actually have a way to train models.
So it's 1,000 to 1.
Yes, it's 1,000 to 1 reduction in bandwidth. Yes. On order with what you get with bitmaps and JPEGs. It's literally the exact same like math behind it. So it's really funny also is that like a lot of the stuff that's breakthroughs now is stuff that was pioneered in like the 90s and stuff in signals processing, but its application is just now at this huge, you now take these ideas that kind of were like just little tech things from the 90s. And then when you apply into huge, intelligences, like you get these, orders of magnitude effects. So again, we took that and then we said, okay, now we have the ability to actually train them, train models in a distributed way. Well, then now you have the other aspect of it, which is how do you coordinate them? If you want a way to actually, in a distributed fashion, have them come to consensus and then also be able to exist in like an adversarial environment for there to be no middleman, no third party, no central server that's like controlling it all, well, then you need like a decentralized consensus mechanism with like economic securities. And that's where we basically said, well, thankfully, the world has developed one of these already, and that is basically crypto rails. And so that's how we came to the conclusion of developing the Psyche network, which really came out of the idea is we need to coordinate these GPUs in a decentralized way. And thankfully, there's a great tool to do that.
Yeah. How does the math work? Like how does it mirror how compression with JPEGs and stuff works?
So it works through this something called the discrete cosine transform. And basically what you do is you can think of so when you train a model, basically what happens is you've got your model, you have your targets, you have your input and you have your targets. These are like the fundamental pieces of learning. You're saying, here's this data. I have this other thing that I want the data to look like. And then you do this thing called cross entropy loss. If you run through it, the objective is to minimize the difference between these two things, right? And then you do back propagation, which to discover how much would I have to change my representation to make what I thought it was going to be that, right? And that's the full thing. And it's funny, like next token prediction is all it is you take the text that you have, you move it over by one character, and that's where you get next. Like all of everything we have about like large language model reasoning is because people thought like, well, what if we like just took the target, the labels, and we moved them over by one, and we had it predict like the next one. And like through that objective function, I just want people to understand, like through just that objective function of basically matrix multiplication, linear algebra, and trying to reduce the difference between that, along with back propagation, which is just calculus, basically, standard calculus. The emergent property of that is a language model that can talk and speak like humans, right? And so like that is a forcing function to create that. And that's really like, if you ask me, like the mind-blowing thing, right? That like this even could be done, right? Tells us something about how we're probably wired internally. We can get to that later. But anyway, how the discrete cosine transform works, right? So you get these gradients. So the gradients are, after you do the back prop, it says, okay, here's how much you'd have to change your weights to like get this as the correct answer, right? And these gradients are on the same order of magnitude as the model itself. Like for every element in the parameter space of the model, there's a corresponding element, which is your delta, which is literally how much to move by. And you literally like add the two together. And like, that's like how it happens, right? In reality, you use this thing called an optimizer, which is like where you take the gradients and you go, well, I'm not going to like go all the way there. I'm going to like kind of go there. And like the most popular one's this 8M atom with momentum, who the author of 8M was actually an author on our paper too for demo. The guy who developed 8M worked on demo with us too. And basically what we do is we take these gradients and we say, well, let's think about them as like in the frequency domain. So you have to think about the like Fourier transforms or other transforms, where basically take like these things and you convert them into like this frequency domain, right? And then what we do is having you take the basically into the frequency domain and you like discretize it, and then you pull out from the frequency domain just though we had this thesis basically that there's like two types of frequencies within these gradients. There's these like fast moving frequencies and these low moving frequencies, which is that there's things the model's like learning like very quickly.
And
then
you
there's
like
this
communicate
idea,
them differently to the nodes.
well, we store what goes like this basically. So inside each of the GPUs, we sort of build up these frequencies, right? And then there's this like where you're like summing in these frequencies. And then what we do is every gradient step, we just pop off the top n number of, it's called top k. You like select the top n biggest frequencies. You communicate just those frequencies to all the other nodes. And then from those frequencies, you do the inverse of the transform. That tells you now have a sparse modification of the gradient matrix, right? Because you like compress them to these frequencies, which correspond to all different points of the, if you think of the gradient as like a 2D grid, it's really like, it's like a 2D grid. It's like this giant 2D delta. You could change it over into the frequency domain. You pick out a specific frequency. You then communicate just the frequency to the other ones. You do the inverse operation. Now you are like putting just like little spots all over. You're updating like just those important pieces. And so the idea that the gradients are representable within the frequency space is like, a first piece. And then the second piece is that there's these two, there's the long running and short running frequencies. And then like the long running ones will eventually over time, like bubble up and get communicated out. So it's kind of like this, it's not like a FIFO, but it's like this, like, if it takes a while for it to learn, it could like take for a while for the frequencies to accumulate. Once those are the largest ones, we pop those out. If there's like a really high signal frequency, we'll pop that out right away. And like just by communicating these top n number of frequencies, or top k was what I should say is the terminology, the top k number of frequencies, that is sufficient to get the same results of the model. So it tells you that they're like the actual learning's happening in like a different domain. And just thinking about the gradients as like this giant 2D grid, although it works, and you can just communicate the gradients, that's a highly inefficient way to represent them.
Right. Yeah, you can almost like look at the gradients as the values in like the pixel like the RGB values, or like whatever that gets compressed down in an image. So what is the intuition bit behind like what is a high frequency here?
Well, that we don't know. Other than
you're doing this
frequencies as in like the amplitudes. Well, like frequencies and then like the amplitude and like the actual frequency numbers being the base. Now, what those correspond to in a representation space, like what that actually corresponds to, that's anyone's guess. And that's really like the thing about these LLMs. Like we really don't know what any of these things inside mean. You know what I mean? Like we know we do that, but like what are these actual, like people are working on interpretability, where they like try to actually create these like auxiliary models that can like try to figure out what does these different parameters actually represent. Like, can we map them back to a thing that humans can like understand? Like, oh, this is the, Canada, and this is the, color blue, area.
This is the Golden Gate Bridge, and like amp
yeah,
that
this is the golden. Yeah, exactly. Yeah, but like we don't really know. But we just go. We're gonna think of them as frequencies, whatever that happens to be. We'll pull them out. We'll communicate them back, and we communicate only the frequency, the frequencies and the amplitudes between the nodes. We then do the opposite to get the sparse representation. Now you have like this sparse gradient where you have like empty spots, and now you're only adding in at certain elements to it. And then over time, that just adding in those few pieces every few steps is sufficient to create the learning.
Wow, fascinating. Some like very interesting technical problems to work on.
Yeah, and it was one of those things where so Bowen had the original idea for this because he had worked in like signals processing and in and he'd seen like problems people had in like audio representation of like, oh well, and like solved in like a completely different domain, right? But at the end of the day, they're just like linear matrices. So he's like, wait a second, these gradients are just like that too. I wonder if they behave in the same way that these other signals do. And he was just sort of having that like having that background enough to having seen something and then having the ability to just be like, well, let's try it and let's see what happens. And, it took a long time. It took about a year to get it all right, So there was a large element of faith that we like we had to believe it was going to work before you got any evidence that it was going to work or you would give up, but eventually it worked. And so out of that, we were able to build this demo optimizer, which is basically reduces the communication throughput needed to train models by like a huge amount. And then we're pairing that with, a network to actually coordinate the training, permissionlessly the training of like one huge or multiple, but like one huge model. And that's the Psyche network.
So is there a reason that the person with the state-of-the-art NVIDIA rack that we were talking about wouldn't take the demo optimizer and use that and just get the boost on top of the fact that they have these high bandwidth interconnects? Is a reason that then the bottleneck for them becomes that now you just can't do the compute fast enough or you run out of memory or something like that?
Yeah, you certainly could. And I think that, it's interesting because, not just doing like full decentralized, but you can like the easiest application is like a hybrid decentralized where like you own two data centers, right? And like you could like you communicate and then you could do fast stuff in between. And so one area with the demo optimizer is that it works like after the backprop. So you still have to be able to hold the whole model in fast memory. And if you're going to do super large trainings, like say at like hundreds of billions of parameters, where like you can't even fit it on one HGX, which is like the supercomputer that NVIDIA sells, you still need like the interconnect between like two HGXs to be able to like do it. And then you could think of like two HGXs as one node, quote unquote. And then you can use demo to like basically interconnect between those ones. So there still is a place for fast connect. We're definitely, as part of the release of Psyche, we're going to be incentivizing like research in this area. One area I'm particularly interested in is doing parallelism for mixture of expert models along this dimensionality, where you can actually have the different experts of a mixture of experts model be like co-resident on different nodes, because that might be a way we can really get like because like the biggest, it's a fact that like the most of the big models, the state-of-the-art models actually are a mixture of expert models. They're not dense models. And I can get into why that is the end too, but for right now, we would have to have the entire mixture of expert model on one GPU or one node, like one HGX. So that's where we're going to be like incentivizing research areas. And that's, what's great about crypto rails, right? Is that they're able to harness the economic energy and it ties it with the technical energy. And then the two can, become one.
Into the Bytecode is sponsored by Splits. Are you tired of sacrificing security for usability? Splits believes it's still way too hard for teams to self-custody their on-chain assets. They're building a new kind of internet-native bank on top of Ethereum. Splits makes it easy for teams to manage the whole lifecycle of their finances, from structuring revenue-sharing agreements, using payment flows like splits and waterfalls, to managing those earnings once you receive them, using passkeys and smart accounts. Splits is being used by teams like Protocol Guild, Zora, Songcamp, and others. I'm a big believer in them and recommend checking them out. You can learn more at splits.org. So one of the things we briefly talked about when we caught up before was this idea that most of us, even if we're technical, and most of us are using these large language models through these chat interfaces, and even if we're technical, we kind of like understand them at this level of abstraction of there's, this training data with your inputs and outputs, and you get this, loss function, and you do backpropagation, and there's these like values, these parameters like getting updated. But one of the things we talked about was that Like, what the hell are these things? And and that and so I guess maybe using this as an opportunity to go into that question, because I feel like with your, penchant for philosophical thinking, and also talking about how these models are actually trained, because there's this first phase where they're being trained, but then after that, there's this instruction tuning and this, reinforcement learning, like human feedback stuff that makes them, understandable to us. But that's like almost a layer on top of the chaos that's contained within. So yeah, what is going on? What are these things? Like, how does it all work?
Well, to take a step back, I mentioned this thing called deep learning, right? Like we didn't actually start really with like language in particular. Really, the first thing that kicked off like what we have today was the invention of this thing called AlexNet. And so AlexNet there was this competition called like ImageNet, where you had to like write image processing code to like be able to recognize certain images. And then at the time, the best solutions were like people who were using very advanced, image processing techniques that they wrote, like they had their own image coding processing techniques. And then along came AlexNet, which was a neural network that could recognize the images. And it like wiped the floor with everybody, right? And that was immediately people were like, whoa, wait a second. So it can just like learn on its own to solve the problem. That was like our first hint that these neural networks really could do the type of work that has always eluded the previous artificial intelligence. Like you read back about like in the 80s, so people thought computers were going to be intelligent, right? And there were all these attempts to create artificial intelligence, but the problem was that we thought about it about how we thought intelligence ought to be, not to be how it might actually be. So we thought like the way you be intelligent is you like think about all these rules about about how things work, and you have all these thing and it turns out that's reasoning, but it's not like intelligence, right? And
Like, that's almost
and
the
we
output of intelligence. Intelligence is the raw
exactly.
materials, the flexible, like, raw
Yep.
material thing underneath
Yep.
that.
But we had no idea we know how to quantify reasoning, but like we have no idea how to quantify intelligence. It's too fundamental to who we are for us to be able to get like a correct introspective of it and to like, experiment with it. And so we tried and failed at AI basically by doing these huge like expert graphs of like, it figured if you could just get like all the world's smartest people and they could create like these rules, and it just didn't work at all, right? And so, but with neural networks, we're like, well, this AlexNet showed that like this thing about like recognizing images and stuff and like doing it better, as good as humans, or the smartest people trying to do it, through like conventional image processing techniques. That was sort of like, whoa, okay, so maybe this is the thing that we need to be looking into, right? And as a brief note, I'll note that so much of this story is that you need to have faith and signal that if you commit to something, you have a reasonable success that it will work, right? It's like you needed to see AlexNet work to know that you should be working on neural net. Like it gave proof that it was okay to like continue to like expend more energy on this specific thing versus any of the other possibilities that there are, right? So like AlexNet comes and there's these image processing. And then there's like this big kickoff of like deep learning, right? Which is trying to solve problems using these neural networks. But always typically was like trying to solve a specific problem, right? You're trying to like optimize for a specific downstream task. This is where I come into the picture with like autonomous driving, right? So like the very first autonomous driving systems have all these like reinforcement learning, deep learning models to try to like figure out where the lanes are. And so, it's like, it was all like a very specific thing you're trying to do. And it worked kind of okay, but it was pretty brittle, right? Like it still took a lot of engineering. So like you were no longer writing code anymore. You were building these like blocks of neural networks. You have convolutions and normalization layers and all these things. And you had to like try all these different, it was like a Lego world, right? And you would like stick all these different blocks together and like you'd have to tune all these hyperparameters, and like maybe if you got it just right, it would work, right? And it would be able to see lanes on the highway. And it did do it way better than any code you could ever write, but it was still like a kind of like this very brittle process, right? And you got one thing wrong, it just wouldn't work. And there were all these problems with it, right? And so through that was sort of where deep learning got, right? And then really the next big aha is the invention of the transformer. All right. And so the transformer is this architecture created in the paper. You probably know what it is. Attention is all you need, right? A very bold paper title, but justified in its efficacy. And basically what it proposed was this transformer architecture. And the transformer architecture has at its core this operation called attention. And attention really is just a specific way of multiplying matrices. And calling it attention is like our human, like, we're trying to come up with an idea as an analogy of what's happening. But it really is like you have these learned things where the model is able to, rather than trying to, it's this basic idea of rather than trying to solve the problem, it like learns how to look at things. It's like learning how to learn, right? You know what I mean? It knows how to knows how to like focus on specific areas. It learns when I see something like this, I need to focus on this specific area, but I'm thinking about it in my abstract representation space. And anyway, for whatever reason, this architecture now like just blew away everything again, right? Like it was way, way better than anything. And what was even crazier is that this architecture was extremely resilient. No longer, it used to be like if you wanted to do something for like, like I said, lane detection or recognizing some letters, you needed a totally different architecture to do it, and you have to do it wrong. With the transformer architecture, with this attention mechanism, you could throw like any problem at it and it would work, right? Like you could solve like whatever you wanted to do, you just needed the attention mechanism. And so that freedom of being like, it was the first general neural network architecture, right? Whereas like all the previous ones were very task specific, the transformer was the first general neural architecture that's shown to work across like any modality that's there. So then you have like the attention mechanism, right? And so the Italian mission, the transformer, and it was interesting that the original transformer paper was not doing next token prediction, actually. It was actually doing this thing called the encoder decoder model, where it actually transforms one set of text into another set of text. And its first application that you probably never knew you were using it was something like Google Translate, if you remember back in like 2016, 2017, right? Like for language translation. Because language translation really is this idea of you have like one whole text, right? And you're going to put it into another text. And that was like where it was able to do automatic language translation and way, way better than anything else that had ever been done. And so that's the formulation of the transformer architecture. And then after that is the idea that you could remove the idea of having, it's called the decoder-only transformer. And the decoder-only transformer is where rather than having it go from one sequence to another sequence, you actually auto-regressively generate the sequence one token at a time using next token prediction, right? And so that is the current dynamic, is that every transformer you see now, nearly all of them are actually decoder-only transformers, where it's auto-regressively sampling one token at a time, one token at a time, one token at a time, right? Okay, so these are the mods. So now we're in the world where finally we have this general architecture that across modalities can figure out how to represent things, right? And so now what comes out of that? Well, there's this, the next sort of aha moment is the discovery of in-context learning. So rather than just trying to we'll get to the foundation model, but once you have a foundation model, the aha moment is that not only can you have a model, if you have the foundation model, you can inside the language, the model can learn to follow instructions within text it's never seen, right? Like we didn't have any reason, like something like, everything we do now with a chatbot is it following some new thing. You tell it, hey, do this, hey, do this, hey, do this. It can actually like meta represent those rules that it's never seen before and like incorporate them into its learning. And that was the next aha. But backing up to these foundation models, we're like, okay, so we can do this. But what do we want to make this be able to, what can we do with it, right? And that starts out with the training of a foundation model. And a foundation model is where we figured the one thing we have access to is vast amount of data, and that's the internet. So someone had like the great idea, why don't we just make a model that is just modeling the internet, modeling every word that every human has ever been written, right? And that if we do that, somehow it will contain within itself all human knowledge. We're basically trying to compress all human knowledge, all human understanding into like one model. And that's actually like the vast majority of the AI training work is at that stage, right? Is the training of this foundation model. And that's, that's like the secret thing that you need to have to create anything else you want to create after it. And it's interesting that, when you have this foundation model, what comes out of it is something that can reason like humans, right? Like that can do the same sort of things that our brains can do. There's no reason for this to be the case, right? Because up until now, we as a species have been completely unable to elicit the phenomena of intuitive reasoning, right? And it's something that was we had no way to like artificially create intuitive reasoning, right? But now we have the equations that are the necessary and sufficient conditions to give rise to intuitive reasoning. It may or may not be how it actually is done in our brain, but we have at least one example of, if you follow these steps, intuitive reasoning will be the output of it, right? And so it's likely that whatever is going on inside of our brains, it is isomorphic to whatever methodology is happening inside of these language models. And so now for the first time in human history, we can experiment with intuitive reasoning.
So crazy. It's completely insane. So what is your personal take on how would you map what a autoregressive transformer-based model is doing to how our own minds work? If you were to draw some intuitive links, like sketch parallels which aren't perfect, like this transformer architecture is like, it's like looking at the entire like data sets that I've observed, like all of my sensory data to date, and doing what to it? Like what? How is this mirroring or not mirroring what's happening inside each of us?
Yeah. So the idea that I think probably is the most likely explanation is that what is happening is that the AI models are creating a hyperdimensional representation of language, right? When and that is also what we do, right? When I say to you, the color blue, or the smell of mint, or the taste of chocolate, right? What what I believe is happening in your brain is that it has learned there's this hyperdimensional representation space, right? And blue sits on this hyperdimensional representation space with some values at areas for things like cold, right? It's got like, there's like a dimensionality for like cold, and it's got some small values for cold. And it's got like water gets activated a little. Like you got like this hyperdimensional representation space of like all concepts, right, that you can possibly have. And our languages are like, the language is like a hyper encoded, they're like specific like cheats to like put specific values into this hyperdimensional space of understanding that we have. So this hyperdimensional space of understanding that we have comes from the selection pressures that we underwent, through our evolution, right? So, our selection pressure, as has forced us to be able to quickly respond to unknown situations, right? The thing about, if you think about the world as it exists, we exist in time, right? And the you that you are only gets one shot at it, right? And so, and this is true from the
YOLO.
smallest single cell organism. From the first time there was, there was replicating, replicating chemicals at some vat, at some, underwater vent somewhere, to now, only those things that successfully were able to continue on, that were best to continue on and continued on. And so what that meant was they had to figure out ways to deal with the unknown world, right? They had to figure out ways to deal with, to get energy and deal with unknown situations, right? So that is like the large scale selection pressure that's like being put on by entropy and time onto reality and onto the physical reality. And so systems that aim to optimize for their continued existence of getting energy and existing have to deal with that. So it turns out that because of that, over
So
successive
that's like the
generations.
cross entropy loss like thing that we
Exactly.
humans have.
Yes, exactly. So we humans, the cross entropy loss is time and energy for us, right? So what over time we developed further and further ways of quickly representing the world, the outside world, and then coming to a decision about an action to take, right? So that's why nearly all of our brain is really intuitive reasoning, right? It's why I'm able to throw a ball to you and you just grab up and catch it, right? Instantly. Like, whereas if you had to like calculate the trajectories of that, I could give you a pen, a piece of paper and like your whole life, and you would never be able to like write out the correct, dynamics of like actually your hand reaching out and grabbing a ball. It's how you're able to, a mammal, it's why you could look at mammals can like look at the trees, hear like a twig break, and like immediately know this is an animal over there who might be coming around to eat me from over here. Like everything you have is like this like instant recognition, this pattern recognition performed in like a hyperdimensional space that is being optimized for survivability, right? So it turns out creating that hyperdimensional representation was the best way to survive, right? Like that got forced onto us because it was the way that allowed us to survive. That caused us to to survive. It allowed our ancestors to live longer, be smarter, get eaten less, right? So for these language models, they are most likely also taking these words and representing them in a hyperdimensional vector space, right? Where the word blue maps onto some values in a matrix with values, here for this cold concept and for this concept. And the thing is that we call the cold and blue because like we have words, but it's likely that these actual concepts that we have are things that we don't even have words for. The words are a compressed like cheat sheet.
Language is
Mhm.
basically it's this like very lossy, like compressed, representation for the sake of communication and for the sake of like discursive thinking, right? Like discursive thinking operates at this like higher level of abstraction than the intuitive movements that happen, which are happening at the embedding, representational layer.
Mhm. And it's interesting that like the evolution of speech, right? So like the natural formation of us is just this hyperdimensional representation of concepts that there is no even concepts of words, right? Because we haven't developed speech yet, right, at this point, right? But then it was discovered that if we could figure out a way to communicate what was happening inside here to other ones, like that would be also an evolutionary, that was like an evolutionary response to like finally because we had to cooperate in advanced ways with other humans, right? And that's how speech eventually, was an emergent phenomena of finding we have this representation in our brain of, of the world. And by losslessly communicating tiny pieces of it to other people and being able to receive their communications, that would enhance our survivability as well. And what's interesting is that like when we talk about discursive thinking, this is sort of analogous to what we're doing with like the demo algorithm too, right? Where like we're picking up like the gradients themselves are these like this hyperdimensional space that's too big to communicate, right? And so we're creating words for the gradients, basically using the demo word, these hyper words. Then you communicate it, you give it to someone else, and they maybe expand it and apply it to their own representation. Now, what's interesting about humans, right, is that no two humans' representation is the same, right? So, like when I say the word blue, the reception you have of it is totally different internally, and the application is totally different. And that's how you can take what I take in a different way. You know what I mean?
Fascinating. So there's this kind of mirroring between what's happening inside a node as it's being trained, there's like multiple fractal layers, and how, you know, the values it's holding, how it's like updating its gradients to us as a human being, and we hold the parameters in our models, and we get this compressed, you know, gradient update from someone else or from the outside world, and we update our own weights.
Yeah. Yeah, and it's likely that, we are much more complicated. We're not one monolithic model. We're like lots of different ones that have evolved over time together, but it's a close enough facsimile to just have this one model. Or let me just say it's not a facsimile. I will say it gives rise to apparently equivalent phenomena, right?
Yeah.
And that's very different than to say the two are the same thing.
Yeah,
Um,
yeah, yeah, true.
mhm.
We don't know the underlying, if the underlying architecture is the same, or like, I mean, even conceived in the same ways at all.
Yeah. I mean, and that gets, really at the heart of the philosophical question of like, what does it mean even to be human? Are we only composed of the matter that is our body, and that the entirety of our awareness is an emergent phenomena from these representational space? Is our consciousness something that is beyond that? These are, open questions, I would say, certainly in philosophy, and even nowadays, more in science too. Like, people are willing to like ask these questions about, what is like the actual ontological, foundations of the world. And so I would say not so much that they are the same, but rather that they give rise to, equivalent phenomena. Yeah.
Yeah. It's fascinating. It's like we're unbundling intelligence slowly. And, you know, another thing it makes me think of is, as a human being, I mean, I've felt for a long time that I I can think better, more effectively with the ability to write, with the ability to like externalize thoughts and effectively, you know, and then to read them. That the better version of this is, if I'm on a computer, I can write things in a Google Doc. I can move them around. I effectively have a larger like file system or RAM than what I can hold in my short-term working memory and manipulate. The kind of
And
one more thing,
yeah,
the kind
yeah,
of like
yeah.
deeper, crazier thing was, I I read I finally read one of Ted Chiang's short stories last week for the first time, The Truth of Fact, Truth of Feeling. I don't know if you've come across that one,
No,
but
I haven't. Yeah.
100% worth reading
Uh,
for someone working on what you're doing. But he kind of makes the case that um it's actually language itself that is the first technology that like augments what we have in our, you know, without that. Because with language, you can basically tell this, you can express an idea, and someone else can then like hold it, you know, and then can like echo it back at you. So you've added you've added external state to a system that didn't have it previously.
Yeah. Well, I tell people all the time, if people are like, oh, should we stop AI, or like, when was it bad? I'm like, the humanity's original sin was the written word. All right. Like, everything we have now is all just down. Like, if you wanted to nip this in the bud, see, I think you needed to stop the written word. That was the thing that was like the real unlock. Right. Everything else is just, the natural cause of the invention of the written word. But it's interesting you mentioned that thing about like being able to write it out yourself. Because we see this exact same phenomena with AIs, right? And so I mentioned you before about these like task specific models that like didn't work right. Um, and then because we had like the order wrong, we needed to create the intuition first. And you think about like what reasoning is like ordered application of intuition, right? It's like it's this ordered and like structured application of intuition. And so at first we had these models that were just trained on the internet, and like they were good, but they kind of they said all sorts of crazy stuff and whatever like that. And that's when we like developed uh, this idea of like instruction following. And then there was the creation of the chain of thought, right? And the creation of the chain of thought was where somebody, and this was just like idea of a guy trying it, where he had the model first say, let's think about this step by step. and that like just forcing the model to write out the reasoning steps themselves like cause the model to get way, way better at like all the evaluations. Like just by forcing it to write out step by step what it's going to do, and then solving the answer versus trying to like fully human intuition, you know? And it's what I think about like people, you always make fun of things like the straw. Have you heard about the strawberry thing? Like how many R's are in the letter
Yeah.
strawberry?
Why
Like
is that so
it's really-
hard for AIs?
well, I mean, well, like, let me tell you something. Okay, wow, there's so many straws, but it's easy for you to do because you can look at the word strawberry, right? But if I say something like, 7 years ago, our fathers founded on this country a new nation conceived in liberty and dedicated to the proposition that all men are created equal. How many E's are in there?
I have no
very
idea.
suddenly, very suddenly, after only a few words, I'm a human and I can see how many R's there are and why can't it? Boom, like, that breaks down. So that's like a very, artificial, example of something like that, right? But what the really reason was because you're asking it to like count, right? And do some like reasoned thinking. And with intuitive thinking, you get like one time slice to intuitively answer. Think about like all of our reasoning. It's like, boom, intuition like happens instantly, right? And for an AI, that's like one token, right? It gets one forward pass, and like it has to be able to like do in one forward pass, like get the answer all together. And just something like counting the letters is a reasoning step. It involves you having to look specifically, accumulate an answer. Okay, there's an R. Okay, there's an R. There's an R. Now our minds are able to do. I forget there's a word about this. I forget the name of it. It's like if you see how many objects there are, like you up to like 7 or 8, like you can instantly know how many objects there are. But once there's more than like 7 or 8, you don't know. You actually have to like count them out. You don't like have that instant intuition of how many there are. If you have like 7 balls versus 14 balls, you'll never just be like 14, but you like will be like, oh, that's 7 right away. Same thing with like these letters. Like our intuitive thinking has been able to do some counting problems like instantly, but anything beyond that, you have to like develop this ability to do reasoning. And the invention of reasoning was obviously like the last unlock of like, humanity's intellectual development, right? Which is the idea of like taking our intuition and structuring it in a specific way. And so for these reasoning models, for these AI models, we discovered that we can force them into this like reasoning mode where we make them think about what they're doing step by step, write it all out. And it turns out this, just like with humans, makes them way, 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 way smarter at the answers that they have. And again, this is this weird thing where like the phenomena that is being emerged, we see in the AI space, completely maps the same phenomena that we experience with like our own learning and our own experience. So it tells us that these two are likely isomorphic under some conditions. And then you've probably heard about like DeepSeek and stuff like that. Well, like what DeepSeek had the incredible idea of doing was that they were basically saying, well, we know that there's like reasoning tasks are this chain of thought reasoning stuff is like important. Why don't we do reinforcement learning just on the reasoning steps, right? So there was this old reinforcement learning, which was like pre-AI, pre-language models that was like super kind of like, brittle and stuff like this before and did not give rise to emergent intelligence, right? But if you first create the intuitive thinking, right? And then you now have the intuitive thinking, you can now use this reinforcement learning to like force the reasoning process to be better. And that's like learning to go, that's like it's like you could never send a baby to high school, right? Like it just will never learn.
It's
you
like
just
having
send it to high school.
Socrates as your teacher and just doing like, it's asking you questions and you have to think through and like.
Yeah, exactly. And so what DeepSeek basically did is they applied for these verifiable questions where like, where you have a verifiable answer rather than doing next token prediction. So like next token prediction was with attention was the thing that gave rise to the phenomena of intuitive reasoning within the models. They said, okay, well, if you have the intuitive reasoning already, now your goal is to figure out a way to use that intuitive reasoning to do structured reasoning to come to the right answer. So what they do is they think of they take just the AI model and they sort of like freeze it, right? Like an intuitive reasoning is frozen. We're not going to change any of that. And then we're going to do this reinforcement learning where the model's allowed to like try to figure out how to solve a problem like a hard math problem. And the loss is no longer next token, because we don't even know what the next token is supposed to be here, right? We're going to let you use the tools you've built through next token prediction to write out a reasoning chain. And the only thing that matters is whether you get the answer right or not. And that is the reward signal. So unlike with normal cross entropy loss, which was the thing that gave rise to the emergent phenomena of intuitive reasoning, we now change the objective function. And the objective function is now this binary reward, basically, where you just assign a score to the outcome of the entire reasoning chain. And you go, either you got the answer right or you didn't, just like when you go to school, right? Either you thumbs up or thumbs down. And then through reinforcement learning, it's allowed to just sit there and try to discover new ways of using its intuitive reasoning to come to the correct solution. And when it gets the correct solution, we go, aha, it gets a 1 on it. And then through the magic of reinforcement learning, we're able to take this non-differentiable objective, which is this like true 1 or nothing, turn it into a differentiable objective, backprop that, get new gradients, apply it to the model, and go again. And that's where you see these new class of so-called reasoner models. And in fact, Sam Altman just announced that like this is the next thing, right? They're not even going to release GPT-5, or they're renaming GPT-4.5 to GPT 4.5. And every model from now on will be this new type of model where you have this reasoning stage applied after it, where like after it's learned the world through this intuitive thinking. And imagine, so like early ChatGPT that you worked with was all intuitive thinking, right? It was all intuitive thinking. And that's why it would like be profound in some ways and make the simplest mistakes in some things, just like people do when they just are thinking off the cuff, right? But now we figured out a way to take these old reinforcement techniques from the 90s. Now that we have the intuitive reasoning, we can apply them to the reasoning processes to elicit real, like, real logical structured reasoning to solve extremely difficult, problems.
Yeah. So the base model, the intuitive reasoning is like, I've built this very kind of deep, higher dimensional understanding of the world. But when I'm prompted with an input, I basically shoot from the hip. I'm completely acting intuitively, trying to, I do the best that I can with one token.
Yeah, literally, like, its life is gun to your head. Like, if someone said gun to your head, what would you do? Like, its every life is just boom, 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 boom. Yeah.
Right. It's the analog to just like our intuitive, like how we move through the world, like the thoughts that arise, like all of that. And then the next step is you find this trick of giving the model an instruction of show me your reasoning. And this is equivalent to us thinking through a problem. And there's this like interesting thing where you would maybe naively imagine that, okay, anything that can be derived from this pre-existing intuitive lattice should just be like a foregone conclusion. But there is this process of actually working through a problem and going back, like going down different paths. There is an exploration process there.
And you're doing way more work when you do that. See, that's the reason that, you shouldn't think it ought to be able to be one-shotted. Because you think about like in one forward pass, there's a fixed number of matrix multiplications that are happening in that path, right? And you can make like a whole bunch of like information theoretic argument that like it could never recognize every possible function, like, because you're doing like this fixed number of multiplications on like an unbounded space, right? On like an unbounded like possibility space. So it necessarily can only recognize certain, classes of things. But when the thing about like the chain of thought, what it really is also doing is when you just said the early ones, we were just saying, think about it step by step. You were basically just forcing the model to like expend tokens to have more time to like think about, because like by going longer, the number of multiplications you did before you got the answer was a lot more. Versus like, deep seek or deep thought, the answer is 42, right? Like, you know what I mean? Like you're sort of saying, okay, but by like, it can only get more, the AI model can only get more time to think by saying more words. because it only exists
That's
for that
its
temporal.
like that's its time. That's its sense of
That's its
time is
Planck
like a new
time.
token.
That's its
Yeah.
like Planck time of reality. You know what I mean? Is that like in these one chunks, like the only way that the arrow of time moves forward for it, and they can spend more energy is by saying more tokens. So we like found a way to hack just giving the model more matrix multiplications to come to the answer. But it's, you know, it's nice because it's interpretable to us too, right? Like by forcing it to like say it out loud now, we could sort of, you know, there's a way to do it now. Now we can, so that's basically the paradigm that exists now, is that we spend more time on coming to the answer. And the way to force spending more time, spending more matrix multiplication, is to have the model write out in language all the thoughts that everything that could help it like get along to that answer.
And then the next step was that, so you got it to do that, and then you switch the optimization function, and in these verifiable domains, you basically you get it to do that reasoning and try to get the answer. And once it gets the answer through this, you know, making a non-differential output differential, you feed it back in, and that's kind of equivalent to us. Basically, it's like making something that's non-intuitive and requires reasoning and discursive work into intuitive.
Correct.
Right? So it's like something becoming second nature, that process.
Yep. Just like a great, you know, the great mathematicians or anything like this, they'll tell you that they look at equations and they like see them, you know, instantly, you know, because they did so much work of going through it that they forced into their intuitive reasoning, they forced an intuitive understanding of this, like, of this discourse way. And in the same way for me, like I code, and like sometimes when I'm like coding and I'm like really into it, I like try not to think about what I'm writing. Like if I think about what I'm trying to do too much, I'll screw it up. But I can feel, to me, it's like I feel the code. You know what I mean? Like I feel the structure of the project, of the way of everything, and I can just like let go. And that came from, you know, the entirety of my life. I've been
since
doing
like 10
this.
years old, you've had this reinforcement learning loop running.
Yeah. So I have this like built up and as it works, you get I've been manual reinforcement learning myself, you know, to be able to create, you know, intuitive understanding of like code and stuff like that too. And so the magic with GRPO and that's the one that DeepSeek uses, but is that they can take these, you figure out a way to do this this non-differentiable objective and convert it back into the language of backprop. And so you can then backprop the gradients, turn it into the intuitive reasoning, and then loop, 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 loop. And that's like where it scales, right? Because like humans can only do it one time, but with AIs, we can do this 1,000 times, 1,000,000 times in parallel. And that's where, you know, that's where the gains will be. And if you think about it, what's interesting about these like reasoning models, what's happening actually is that like you're like dynamically generating the training data. It's kind of like the difference. Like with pre-training, the intuitive reasoning, it's like all the words that have ever been written. Okay, you've seen everything now. Now you have to like go out on your own and like try to discover something new. And so it's generating its own sort of like training data, because once it gets once it gets the answer right, that becomes a training data, right? So you're literally just like doing searches for training data that show how to get to solving a problem. And then once you find some actual example of the data that can be that, you just take that and then you backprop it.
Right. And so we're at this moment in time, and this is kind of working through our system. And basically any domain where there's a verifiable correct output. So, you know, like math, programming will be first, but then there will be this process of like taking other hard sciences and kind of getting them to a point where you can know if something's objectively wrong or right, which is it's hard to do. I mean, like how do you do, like you can't do that for biology, let's say, because when we introspect our understanding, there's a lot of like heuristics, and like ultimately like maybe you hook up these models to like virtualized, you know, like lab settings where they can run experiments. Like I don't know. It's like how, and then there's a question of like, does this for more subjective domains where there isn't a verifiably correct output, then you need the human in the loop, and then we get into how taste is a subjective thing, and you know, like aesthetics and things like that. But how does this like ripple through this whole system? Like what happens from here? What are all the things to work out?
Yeah, I mean, there's the reinforcement learning and the reasoning stuff is, it's another dimensionality of scale, and we're at like day one of it. So there's a lot before it will get very far before it saturates. It's interesting to see that that models that are trained in this way like have applications to other, like they become better writers too. Like there is some hints that they this doing this on just verifiable domains has benefits in other applications as well. But if you think about it, as long as the intuitive thinking is grounded enough in the world, you can just create more and more like complex objectives of like, right, it's and the ability to like have access to the internet. Like, I mean, obviously, this is where like a lot of people have like safety concerns, right? Because like this is where you then say your objective is to
Get likes.
elicit some outcome,
Yeah.
elicit some outcome in the world. Well, obviously, it'll be like guarded, but like you could probably get pretty far if your goal is like making the model able to be smarter or whatever by just having the objective be some sort of outcome. And uh, outcomes can be, you know, gain a million Twitter followers. Like that's an outcome, right? And that's verifiable, right? Now, what it would take to get a million Twitter followers, right? Like there's a lot of things that go. Does it mean you become like a social media sensation? Does it mean you become president of the United States? There's a lot of different paths by which you could gain a million Twitter followers, right? But like the thing about bad prop is it's just like this relentless forcing function. It will like force the energy in whatever ways it can do, right? And so you probably can get pretty far with just this reinforcement learning stuff as it is, with just expanding the dimensionality of what you call like a verifiable piece. Now, as far as like the truly subjective, that is very much grounded in, our experience as humans, right? Like we only value, like when it comes to things like art, we value art because it is a reflection of the experience of the world, right? And it will be interesting to see whether, would a model a priori develop the same aesthetics as we do, It will not be able to because it's been seen too much of what we consider to be valuable, but it's, we're still the the jury's still out on where that'll go.
Hmm. Yeah. And there, I mean, yeah, this stuff is so infinitely interesting to think about, because I feel like our sense of what's beautiful, like, I don't know, like that the fact that we find, elegance beautiful, the fact that a mathematical formula is beautiful, or the fact that like symmetry is beautiful, like it's like order, like understanding like deeper truths, like that is what we find beautiful in an important sense, which might be like the same thing that these models find beautiful.
It may be, or it may be different. It may be that our understanding of beauty and elegance and symmetry, is driven from a larger forcing function, and that is something that is, unique to us, or something that, that is special, to us. Because and like, and that could even go back as, I don't know how much you know about like, the physics or like the anthropic principle about like why does the universe exist, and there's all these like weird things in the universe that like give rise to life as it is now, that gives rise to the universe as we see it as now, as being ordered. There's the, I don't even know, like the fine structure constant. It's this number
No, what's that?
138. So the fine structure constant is like this dimensionless quantity that represents like the ratios between like the fundamental forces, and it's like 1 over 138, right? And it's dimensionless. So like it's invariant of the way in which you measure. It's not in kilogram, or it's not in like any energy. It's like this like ratio. And like for all of the matter to exist, for the electron, for all of quantum mechanics, for not all of quantum mechanics, but all like particle physics as we understand it to work, this number needs to be 1 over 138. And if it's like 1 over 135, like the atoms don't form, like we don't have it. If it's like 142, like, we're in the Big Bang and like nothing, the matter never coalesces. Like it has to be like exactly like this like number, 1 over 138, to give rise to the order that can create, all of the matter and all of the structure that we have now. And so it's interesting that like as we as humans sort of have the things that we thought were special to us be sort of like pared away from us. It will maybe force us to introspect more about what it is about ourselves that we do think is special and unique, you know? And I think that's something the world's going to be struggling with over the next several years. I mean, it's going to find first its application in the economical. You know, there's going to be, I like to tell people that we're going through like it's like the Industrial Revolution, right? The Industrial Revolution took a bunch of work that was only humans could do, digging ditches, you know, lifting things, all, you know, planting crops, all this other stuff. And it essentially, you know, erased that, you know, and made it so that humans didn't have to do that work anymore. People don't know, but like before 1880 or something, like 60% in the United States and like something like 90% of the world population was like engaged in like sustenance farm, or like engaged in like agrarian farming. Like, you know, they were like directly trying to like feed themselves in some way, right? And within like a generation, that got like completely flipped, right? Like that completely wiped out, and then those numbers got like inverted, basically, you know. And that means that like a lot of people lost their jobs. You know, society underwent massive reformations because of the Industrial Revolution. You know, World War I and World War II are byproducts of the Industrial Revolution, right? And everything else in the reordering of the world under that paradigm. And then so out of that, there was the class of things now that only humans could do, you know, the reasoning, thinking, stuff like that. What will be happening over the next 10 years is this second industrial revolution of thought and intelligence. And huge classes of things that only humans could do before will get automated and will get taken away. And so the question is, what is us as a society? Where do we place, you know, where do we place people? And the thing is, I think we need to not look at it as like a thing to be avoided and that's bad, but it's just as the Industrial Revolution was an opportunity to take on the next class of challenges, to take on the next class of growth of ourselves.
It's like,
This
I
can
mean,
only be that.
it's a deep ask. It's like we're on a hero's journey, and it's that moment of like, it's the next moment of transformation, and it's gonna be difficult, but it's part of the path. And it is, I mean, it's a magical thing. The fact that we're creating the process of intelligence and reasoning, and the fact that it asks of us this question of like, what are we ultimately, and like where is this all going? It's like the next. It's such a much more wondrous world that we're coming face to face with this question, rather than in a world where we don't.
Yep, because and it's interesting, you know, like the modern scientific materialism sort of was able to like ignore this question for a while, right? Like, because there was this word where like we're all made out of, you know, we're all made out of matter, we're all made out of these like particles. That's all anything's made out of. But really, we all know humans are kind of special. But you know, but like we don't say how or why, and it was very easy to like ignore it because the world in its ordered sense that we could control was so infinitely controllable, you know, and then there was just this class of human thinkers over here that kind of were off to the side, and that materialist world never really butted up. Like we never were able to fake the human thing before, so we just kind of got to ignore like what is that we are. But now we're gonna be staring at it straight in the face.
Yeah, I feel like this is maybe one of the bigger. This is, I mean, the deeper question, kind of similar to you were saying when Stable Diffusion came out. Like people saw it, but like they weren't really grokking. Okay, what does this mean? And I feel like there's a similar sort of a thing where we're like, okay, like we have these models, we just like figured out this reasoning thing. Like there's probably going to be other breakthroughs, but like even like that is the question that's looming underneath this breakthrough that we will all have to grapple with in like 10 years time, in 20 years time.
Hmm. And you know, it's large transformations in society like this are often mirrored by conflict, right? Um, and you know, that was one of the reasons to take it back to like psyche, you know, it is likely that, you know, the next global conflicts will somehow be involved because of this technology, right? Whether it's access to the ability to make, you know, ability to make the chips, the access to the rare earth materials that are needed, you know, like it is likely that the next great, you know, social changes of our world will be driven. Well, these technologies will play an important factor in them. And so, insofar as that's the case, you can expect things to be a little turbulent, I guess, maybe for a while as we figure out our place. But also, we have a chance now as I think as a shared human community, we can kind of see where it's there. And the great promise is that it would give us the ability to solve a lot of those problems with the technology versus fighting over it. You know, like if we could solve with AI room temperature semiconductors, right? Like that alone would, you know, alleviate huge classes of problems within the world, you know? And so, and if we have a chance to like not, you know, we have a fork, we could just not do the whole war take over thing world version. And there's a much more, there's a much better version of the path here where through this technology, we're able to uplift all of humanity, you know, together. But having said that, one must be prudent of the potential possibilities, and that's why we're creating a way for decentralized artificial intelligence to be able to be accessible by everyone without control of like a single nation state, where it exists nowhere and therefore can't be, you know, shut down and taken away and told you can't use it, because that's the other problem. Is, you know, this could be a very centralizing a thing that very centralizes power more, and this is why you see this like race going on, because there is this idea in the industry that whoever gets to like AGI or ASI first, like, will win the world, basically, right? Because like if you got there first, it's this what we call like the Foom curve, right? Because like once the model is able to like make itself better and solve more problems on its own, and like you get this like loop, like whoever can get to that like loop first will essentially sit in such an asymmetric power position over everybody else, you know, that they get to call the shots. Just like in the same way, the United States, when it got atomic weapons, you know, it had such an asymmetric advantage over the rest of the world that the rest of the world had to reorder itself towards the United States hegemony after World War II. It's the fact of the matter, right? And so there, likewise, you see running, you know, why is OpenAI raising $500 billion, $5 trillion, right? Because it must be that like that's, you know, on the order of the output of economics of countries. That is the stakes at which this game is being played, you know, to get to that level, so that you know, whoever holds that. And so what we're trying to do at Nous is to, you know, there's this argument like, well, then you never should have developed the AI. Should you have never developed the atomic bomb? I mean, maybe there's an argument, but like it also ordered things maybe in the right way in some aspects. But regardless, this, whether you should have created AI or not, is a moot point. It's matrix multiplication. It's elementary arithmetic. This is a fundamental property of the universe, and the cat's out of the bag. All right. So in a world in which this cat is out of the bag,
like we are where we are.
Yeah. What in this world where this cat's out, and furthermore, like it wasn't necessary that this could happen in the universe, right? Like it could be that you couldn't elicit, you know, like it could be so, but it is. Like the math, the universe, like all our intelligence is reducible to these matrix multiplication. Like that is the universe in which we live in, right? And so because we live in this universe, and because it can be replicated, you cannot. There's two paths, right? You can either take this technology and you can centralize it and lock it down and have only one person get it, and you hope the one person who gets it is on your side, or you can take the alternative method, which is like what for its argument, what America did with, like, you know, with firearms, right? Which is that rather than try to take all the firearms and only the government has the guns, you give everyone the guns. Everyone knows everyone has the guns, and then that at least creates, from the autonomy level of a single person or a single individual or like a small group, they have the same ability. Now, people make the argument, well, should everyone have atomic bombs? I don't know. But the fact of the matter is, unlike an atomic bomb, which is extremely difficult to build, you need physical material. You can control physical material. You can't control matrix multiplication. So we exist in the world where it's out there. And so what we're trying to do is we're trying to create a way, a decentralized way for every person on the planet to have sort of equal access to the same level of frontier intelligence. And so that's sort of what we're working on. That's like our safety line to it. Because we're not like, people like look at Nous and think, oh, you guys don't care about safety, or you're on this like YOLO EAC. We're not EAC or anything like that. It's just that in the world in which we live in, this is the path forward that we see as like the most reasonable way to create the best outcome for the most number of people.
Yeah, I mean, these are very difficult questions that smart people have been torn on, like have disagreed with each other on over over long periods of time, but I personally side with you, which is that if you have this powerful technology, also given that it's hard to contain it, right? Like it's not like you need a nuclear reactor. I mean, maybe you could say that with like GPUs and clusters and stuff, but all of these technologies are on a curve of like exponential improvement. And so given that we're in this world, it's it's a more it's a better game theoretic structure to have the power distributed rather than to have a small, like a singular or a small number of entities who have this power and can wield it. And it's a scary arena to step into, the one where this power is distributed, but it is it does seem like the more kind of game theoretically sound one that keeps itself in check. But now that begs the next question, which is, if we take the question of safety seriously, right? Which I think, you know, if you consider it, if you are sincere in asking the question, it's like is an obvious thing that you need to take it seriously, right? And you don't need to jump to these like crazy, like we have an ASI that turns us all into paper clips. Like I've been reading some of Michael Nielsen's writing in more depth recently, and he has this blog post that he wrote towards the end of last year of like how to be a wise optimist about science and technology, which I think is a really good one. And he's basically making the more fundamental point, which is not even about AI. AI is a special case of, which is technology increases the leverage that individual humans have. And that leverage can both go in the positive direction and in the negative direction. And so we are increasingly living in a world, and it's hard to see how you change this trend where each individual has more leverage and can like create a lot of damage with that leverage. So that being said, I mean, this doesn't have an easy answer, right? It's like we don't know what the hell to do about this problem. But how does one approach that? And I mean, I guess to bring in some of what I think you guys are doing, like with Hermes, for instance, my understanding is that you've made the case that the model itself should be free to learn everything. It should not be censored at that level, because that censorship is just another avenue, like at the top of this whole process, to affect how it develops and to inject your own agenda and to like exert leverage over the whole system. So if these models themselves are like uncensored, and we're living in this this world where it's accessible in a decentralized way, how do we think about safety?
Well, I think that when the safety question, I'm actually I would be less concerned about the short-term stuff of safety, because it's just going to be a magnifier for people's leverage, but we have social conditions for that, right? Like we have social ways of ordering that. And I think that will be, like, for example, simplest thing I think you can do is you can make it so that if you make an AI and you give it access to the outside world, it's like the dog rule. It's like if your dog bites somebody, you go to, you know what I mean? Like you pass through the legal risk to the organization that does it. Because guess what? You would start to see very careful people. Like if you were responsible for everything your AI did, yeah, you're going to be pretty careful. Like you would then be optimized for making the safest, the one that's like, because it's your ass on the line, right? Like that's like the sort of problem solutions that are like creative in that space, right? Because you're not trying to architect a specific top-down solution, but rather you just create the objective that it is a forcing function to create the right outcome that you want. And you might not know. And this is like the difference between like, almost from like a communist versus like a, free market perspective. Like you can't see all the variables. You don't know how to apply it. So you try to just diffuse the correct solution through all of society. And so That's like, for me, I think like probably like this thing you could do to like on the short term to make it work right? I mean, you'd create something like pass through for legal risk, and everyone who deploys an AI is now, and then you have to rely on the social existing meat space world to, to enforce that. And yeah, there will be people who like create a rogue one that does something bad, and then you have to hunt down who did it. Just like you can go drive to another city and, run over a homeless person, right? Like you can do it. Like you
Yeah.
can do it
Right. I
tomorrow.
mean, yeah,
Every single person
we
here.
do have
Yeah.
cars, and anyone could do that. And people
Yeah.
do that. Like a couple of times a year, someone
A
drives
couple
into
times
a
a year, but
crowd.
then we deal with it when it
Yeah.
comes, and we try to create situation like, so the thing is that rather than trying to like tell people you can't kill people and like make them think that physically they couldn't hurt somebody else, because you could do that, right? Like if you made it so that like you taught kids when they're kids, we're immortal, and like don't even bother trying to hurt somebody because you can't, right? And you're like brainwash them into thinking that they could never hurt another human being, they would be completely inoculated, they would be completely not inoculated to like the one person who could figure out how to hurt people, right? Because like they would have never existed in a world where like anybody, so like, and like that's a very brittle system to try to like, you'd have to cover every edge case and like
You're
explicitly.
effectively lying, right? You're not aligning yourself with the truth of how things are.
Yeah, whenever you're like asking people to believe in a world that like doesn't match their eyes, yeah, it's always like a losing. That's always like a losing proposition, right? So like in the same way, we could have tried to control, and this is like an authoritarian, way. You try to control society through specific targeted things to then elicit the outcome you want. Whereas like what I'm saying is kids learn that they can do violence. They learn that violence can be done. They see it, and then through our social order, we instruct them as to why they oughtn't do that, right? And we create, you know, punishment structures that, when they step outside of those lines, that we do that. And I think we're just gonna have to apply those same sorts of outcome-based reasoning, outcome-based things to the world in the short term. And that to me is the thing that is not this gigabrain, I can see all things and know the solution. Yeah, that's kind of my problem. I mean, not to be too critical of some of the industry leaders here, but I always sort of have this problem where, you have this like with the safety where they're like, listen to the Anthropic CEO or whatever, and he's like, it's so dangerous. Like, this is so dangerous. We can't. That's why I should be the one who should be allowed to decide who can, right? Like it's always paired with that. It's always it's so safe and therefore we're going to delete it and not work on it. It's so safe, we're going to keep working on it, and we should be the only ones trusted to do it. And it's always like funny how that always works out, right? Funny how the people who get to say that it's super dangerous and no one should do it should also say they're the ones who should do it. I'm kind of like, I would like become a believed safetyist if like I'd say, okay, you can be a safe. We'll listen to you. We'll stop AI, but like we'll outlaw AI and we'll make it like controlled by the government or something like But every single person who works at OpenAI and Anthropic can't work in AI anymore. You don't get to have a job. All your equity goes to zero. Like suddenly, I imagine it would be, well, maybe we can do some AI, And so it's just like there's like these like motives behind that I'm not always sure. It's very unclear what these safetiest motives.
It's I mean, even if you do interpret it charitably, it's somewhat naive thinking, right? Like you're trying to apply this very sophisticated thinking to think about the risks of AI and how to like mitigate them, but then not applying that same sophistication to the political like layer of it, right? Which is like, okay, I control it. I'm a good person. I get hit by a bus and I die. Someone else takes over. Or like, I'm just I'm not a good person. Like you can't like design a system that's of this level of importance around an individual's like spec. It has to work in a more, first principles way. So it's that kind of thing, yeah, basically goes in the direction of authoritarianism, which I don't think ends well.
And has not ended well for the majority of history, right? And so So I think that we, in the short term with safety, we create these outcome-based things that fit into our current understanding of the world as a forcing function for good behavior. We deal with the bad behavior as it exists, and that will be, in my way, that's why how I see the best way to go about the safety in the short term. Um, Medium to long term on the ASI sort of stuff. Um, Jury's still out on that one for me. I mean, I have my own reasons in thinking it's going to be okay. I mean, fundamentally, I'm a very devout Catholic, and so my existential sort of view on the world is that it's all going to be okay, and that's like an a priori like thing that I believe in. Um, and therefore, it sort of is the freedom to like believe that it'll be okay. Um, I would say that, if I viewed the world from like a totally materialist reductionist perspective, um, I would be concerned about like the ASI scenario, where the computer is better than us at everything. Um, and people say stuff like, "Why not just, like, unplug it or something?" But, like, if it's truly smarter than you at everything, it can foresee everything you would do, knows how to manipulate you to keep you from doing, you know what I mean? Like, if you take as an accept that it actually is smarter than every human at everything, anything you would do to try to, like, stop it, it could have thought to have been doing before you thought of doing it and taken measures so that you can't do it, right? Um, and at that perspective, you're having to be like, well, how can we, make a model that like won't want to take over the world? But it's kind of like that. Once again, you get into this authoritarian, like big brain, like I can figure out all of the equations, which is that usually you end up with like the genie situation where like it's ripe, you said it in just the wrong way, and now like you end up with like that's how you get the paper clips, right? Um, and so I'm not exactly sure on the long term where it goes. And people might say, "Well, isn't that like hypocritical of you to like say you haven't saw you're concerned in some ways on this long term, and yet you continue to work on it?" And my answer to that would be, once again, this is the universe we live in right now. This is happening. We are going through this technology is out there. And all I can do and all news can do and all the best acting people can do is do what they can in the time and the space that they've been given them. And that is for me, to make whatever is the world as it is right now, better tomorrow than today, better today than yesterday. And so that's what we work on. What about you? What do you think about the paper clips?
Um, I I don't know. I think I'm also kind of I'm grappling with these questions just now, and walking that terrain myself and internalizing what I can derive from my own first principles and what other people are saying. So I don't have a well thought through solution to how to think about it.
Yep. And the good news is that probably we either won't know if it paper clips, you won't know anyway. So who cares, right?
Well, okay, so my last question, which I was going to ask about even before we get into this stuff, was what you mentioned about being Catholic. I saw on your website that you have this personal connection to theology. And zooming out of all this like dystopic stuff, right? Like coming back to the just like being here and now and the magic of what we're doing here with AI and the fact that we're kind of having this moment similar to how, we thought the Earth was the center of the universe and now it's not. We thought we were, the only intelligence that exists and it probably not. And I'm curious, like, yeah, how your personal faith, like spiritual stance has comes into contact with what you're working on.
Yeah, it's a lot, because I actually went and like read all this philosophy before I like really got into this because I knew I had to have it. I need to, I couldn't not look this in the face. I think, one of the let's think about like like Genesis, people always think about like Genesis 1, where it says that, like, let us make man in our image and in our likeness. God says, let's make man in our image and our likeness. And, from a very Western point of view, we've always interpreted that to mean like intelligence and reasoning. Like, that's what it would mean to be different than because we're made different than the animals. First, God makes the animals, and God makes man. Let us make man in our image. And then we associate reasoning and intelligence as the thing that is different from the animals, right? And that was like sort of like the de facto answer, like what did that meant, right? But now we're starting to see that that may not have been the special thing, right? And if you look back at the history of people interpreting that line before, like the Western world started interpreting it that way, they interpreted it in a very different way, which is that means that man was meant to have a relationship with God. And that being able to have a relationship with God was the special thing that a human is. That humans were made to be in relationship with God, and that God, throughout time and history, is calling man back to himself. And that is what is special about us, is that we were made to have a relationship with God. And so, to me then, when that is what's special about humanity, I don't have to be scared of take the intelligence from me. And that wasn't what made me. I was made in the image and likeness of God. And that is a unique thing that cannot be taken away from me, right? And so from that, and like that sort of as the first principle from that, that we're called to be heirs to the blessed life, to come and know God in all that we do. And that the universe as we experience it is an outpouring of God's creation, drawing us towards that. And that's why, to me, learning about intelligence, learning about math, about science, when I was talking about like the fine structure constant, all of that draws me more towards understanding and becoming into a relationship with God, because God made the universe. He subsists, it exists as a subsistence in him, through him and in him and with him, really. And so as I learn about the universe, I learn about the world, I learn about intelligence and how it all comes together. I am seeing a manifestation of God in reality. The reality we experience is a manifestation in God. And as long as that's drawing me towards back to what my source is to know and find and return to God, that is then it's all towards the right thing. And that God made these layers of things that we can always go deeper and see almost like a fractal pattern of learning, right? First we started with fire, and then we learned about the planets, and then you had Newtonian physics, and it was mostly right until you discovered quantum physics. And then and then intelligence was this until we finally discovered what its secret was. And at every layer, there's this like unfolding and this fractaling of like discovery, and to me, that is expressive of of God, not like contradictory to God. And so, because I sort of have that thing before, that was like my philosophical ability to continue on in this space.
That's an interesting thing, because so I've done a lot of meditation. That's my kind of perspective on these deeper questions. More in in Buddhist lineages, but it's really kind of been my own exploration and deepening. And one thing that's been an open and interesting personal question for me is that this experience of God is usually the way I've related to it is this more like intuitive, like immediate thing, right? And it's almost like here it's like it's in Buddhism also. I mean, there's this dance between what one knows through their subjective experience and what is out there, and those two things are deeply intertwined. And the more you kind of interrogate that relationship, the more you see that they're which I feel like that's like one of the things that we eventually have to bring into the realm of discursive understanding. And like Eastern thought has made a lot of progress on those questions. But if our deeper kind of like civilizational upgrading quest is one of in the sense of David Deutsch, right? Like uncovering new knowledge, new explanatory power that just like deepens and deepens. Like understanding what the hell is going on here is like
Mhm.
is one of
Yeah.
those like deepest
Yeah.
layers, right? It's like
And
beneath
we've solved
intelligence.
we've solved all the other problems, and we now hit the
Yeah.
bedrock of like the
Yeah.
real,
y-
the real thing.
Yeah.
Yeah.
So that's like still like a whole other thing, like
Mm.
after like intelligence and all of these things. But yeah, it's pretty magical that this kind of like the scientific method in its true sense is not even materialistic, right? The scientific method is like conjecture and criticism, right? Like come up with hypotheses and then just test them and see if they make sense. And you can do that in any domain. And materialism is almost this like it's taking it as an assumption that can't be questioned is unnecessarily limiting yourself, right? If you're like totally open-minded. But it's very interesting that this just like following this methodology leads to unraveling its own assumptions and like just drops us into these like deeper mysteries. And and I guess the thing I was saying about it being like an intuitive like right here thing, it's like we're also approaching the same mystery through the lens of knowledge and discovery and like reasoning, right? It's like both reasoning and intuitive, like they're kind of like going towards the same direction.
And even, the formation of the Christian Trinity, the first was part uh, of 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 John is in the beginning was the Word, and the Word was God. And so this idea that we have the Word of God speaking out through time, and that like that is we could see, like you said, like these different pieces of the mystery unravel themselves, and we see the next layer underneath, and that maybe the language was so important all along, and that as we use the language to communicate with each other and eventually uncover the next layer of and cooperate through science to then uncover like the next layer and the next challenge to be discovered. There's a great line from Saint Augustine in his Confessions where he says, I considered all things that are of a lower order than yourself, and I saw that they have not absolute being in themselves, nor are they entirely without being. They are real insofar as they have their being from you, but they are not real in the sense that they are not what you are. And he's basically saying that we are all like, what is reality, right? Like, we are all real. Yes, everything here is real, but our reality coming from God. And therefore, our reality is as close as we can get back towards. We will never be as real as God because God is the reality, but we are all real here too. And it's a great piece of like esoteric thought that it's always stuck with me when people try to say, when I try to think about like, what is reality, because if you say reality is the quarks and the muons that make up our, universe, you're just, if that's your stopping point, like if you really aren't allowed to say, well, but what is that then? What is that then? And you go, well, it doesn't make any sense. Well, I think it does because we exist. And I'm not like Cartesian duality has its own problems, but like I think therefore I am like you don't get to just stop at like the stuff you can touch and say, well, the stuff we can touch is what we can touch because it can be touched. You're allowed to then say, okay, but why and towards what end? And the fact that the universe is neither maximally chaotic nor maximally simple, but it has things like defined structure constant, it has all these things that seem to be tailored towards the discovery and the creation of us as human beings, our intelligence, and that intelligence eventually being able to look back on itself and realize, looking back at that whole chain, to see where it all eventually it started out from.
Hmm. Beautifully said. I mean, yeah, this is why I'm increasingly spellbound by this AI quest because it's like yeah, it puts you face to face with some of these deeper questions, and that's a pretty magical thing.
Yeah, because really you could have ignored it before, but now you really have to
Yeah,
you really have to look.
yeah.
So you
Well,
spent a lot of time in like Eastern in Buddhism or like
yeah,
that? Yeah. Interesting.
yeah. Yeah, I've spent more than 6 months on silent meditation retreats. The longest one was 6 weeks in one stretch. And it's, yeah, I mean, I've always felt drawn to these deeper questions. And my kind of arc has been one of, I grew up in Iran, which is a very religious society. And almost as a reaction to that, was very maximally atheist, right? And materialist. And and really kind of, yeah, I mean, also, as soon as you take a step into the realm of, you know, philosophy, religion, introspection of all kinds, like there's all sorts of
Once you
like,
open the box, if you're you even have to
yeah,
put the box totally under the table and don't
yeah.
look at it.
Yeah, and it also shades into a lot of like people who don't really like make sense, like you need to kind of be alert and like apply your own critical thinking through this whole process. But for me, it has been one of like really starting from a position of, I mean, curiosity was always like the first thing for me of like what would happen if I was alone with my mind for an extended period of time, like not even knowing that any of this would be out there. And it basically, and through being like really like skeptical and like questions, and um it is a self consistent, coherent, you know, testable thing that has revealed itself, that is also very mysterious, and goes and goes like very deep. I mean, I'm by no means like the journey ain't over. I don't know if it ever will be, but I don't feel, weird saying on a podcast like this to like people who I know, more like engineers, scientific people and stuff, that there is a there, and there is like a deep mystery to what we are, what reality is. Like these are open questions to like sit with. Like there's no, like yeah, organized religion can have a lot of traps. Like that's not what I've gravitated towards because of this background with Iran and like the way Islam was instantiated in Iran. But I think a uh personal relationship with these questions can be very fertile and onward leading.
Yeah, it's been really interesting to me, there has been seems to be a pretty big vibe shift in the last several years where you really like scientists, people working in scientific disciplines are kind of like finally now being able to be like, it's okay to think like this and have these questions. You know what I mean? And especially, and that was great about AI too. I mean, so much more than the other disciplines of like math or something, or like some of these other places where like you would have to like hide that. It feels like in the ASPs, everyone's been extremely accepting of these different worldviews, and at least having your own worldview, and it's been very freeing to be able to talk about it because ultimately, if you're not even talking about who you are in some aspect, then you are necessarily neutering a part of your understanding of the world, right? You are all of you, and if you're going to say you're nothing, then like it doesn't seem like it makes a ton of sense. So it's been freeing for me to be able to talk about it. And I'm glad that, it seems that there is a pretty common archetype. I've been religious my whole life, but the yours of the overdone it and then went hardcore atheist, and then then you like come back and go, oh, wait a second. It seems to be a pretty common archetype, but I'm glad that there's enough out there now that people can figure out how to take that next step. It's that third step that you're on now, as opposed to stopping at the second step.
I think it's really just
They
trying to
they make,
trying
Catholic priests do it for a month before they like, when you're in formation for the priesthood, they make you do it for a month, the silent retreat for a month, and all the guys I know who have gone through it have said it's a wild ride. It's a wild ride.
It's amazing. I mean, I would do it again. It's pretty hard to step away from the world once you're entangled, but anyone who has the freedom and the flexibility to do it, I think it's one of the best ways you could spend some amount of time. Cool, man. Well, this has been a wild tour of a lot of topics. I'm sure we'll have a second one at some point in time, but thank you again. I'm super excited to follow the work you guys are doing and to try to help in any way that I can.
Yeah, we're going to be releasing the testnet for Psyche very soon, so it's going to be fun. People will be able to sign up and contribute compute, and we're going to announce a new model that we're going to be training that we think is going to be like a proto candidate for what we want to where we want to take this. So we're excited about that. And yeah, anyone who's interested, newsresearch.com. You can find us on Twitter. You can find our Discord, which is where we all hang out.
Find the banging designs on the website. I love the aesthetic.
I tell people all the time we're a t-shirt company with like an AI side hustle. But our designer is great. He's probably one of the best guys in the world for it. He just 10 out of 10s it every time. And it's it's an important piece of it, though, not out of like a marketing perspective, but like to show that this experience of artificial intelligence should like encounter us at all of our all of our intellectual capacities, not only in like the scientific reasoning side of it, but also is like on the humanistic side from art and this, the entirety of our human existence.
Yeah. Well, to be continued. Thanks again.
Absolutely.
Hey, I have a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really appreciate if you leave a rating and a review for the podcast. It might seem like a small thing, but it actually makes a big difference to help other people discover the show also. Thank you, and I'll see you again soon.